Hello everyone, welcome back to my channel. So in this video we will learn about harmonic functions. Harmonic functions. Okay, so about harmonic functions, second is about conjugate harmonic functions. Right, conjugate harmonic functions. Procedure we'll solve. Okay, so we'll learn the procedure how to find the conjugate harmonic functions. Third is orthogonal trajectories. Okay, so these are the topics which we are going to learn in this video. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. Right, so harmonic functions. So if you are given with a function f of z is equal to u of x comma y plus I into v of x comma y. Okay, a complex function is given for you. Okay, so u of xy is the real part, right, and v of xy is the imaginary part of f of z. Okay, so if you have u, so if you are given with any one of this, either u or v. Okay, so if you are given with u and ux comma uxx uy comma uyy are defined and continuous, and if uxx, so after finding uxx plus uyy is equal to 0, then u of x comma y is called harmonic function. Similarly, if you are given with v, so vx, vxx, similarly vy, vyy are defined and continuous. Then if vxx plus vyy is equal to 0, then v of x comma y is called harmonic function. Okay, so what is the advantage of this harmonic function concept is, if you are given with only one part of f of z, that is either real part or imaginary part. If real part or imaginary part, any one, okay, so any one is given for you, and you are asked to find the analyticity, to test the analyticity, that is whether the given function f of z is analytic or not. You are asked to test the analyticity. Then if you are given with the real part, if your real part satisfies this equation uxx plus uyy is equal to 0, then it is said to be analytic function. Then it is said to be part of analytic function. That is, it is said to be real part of analytic function. So that means you can test the analyticity of a given function by this formula. Okay, this can be written as dou square u by dou x square. Uxx means dou square u by dou x square plus dou square u by dou y square is equal to 0, or we can write it as del square u is equal to 0. Okay, this is del operator. Okay, so we will learn about this in vector algebra. So del square u is equal to 0, right? So dou square u by dou x, that is differentiated two times. Differentiate u with respect to x. Two times. Similarly, this differentiate u with respect to y two times. You will get dou square u by dou x square, dou square u by dou y square. Just add them. If that value is equal to 0, then the given function f of z is said to be analytic. That is Simply harmonic functions are used to find the analyticity of complex function f of z. Okay, so if this condition is satisfied, then u of xy is the real part of the analytic function f of z. If this condition is satisfied, then v of xy is the imaginary part of the analytic function f of z. So both represents analytic function only. So these are the conditions used to test the analyticity. Okay, so whichever is given for you, you just find that if you just find the corresponding equations are satisfied or not. If they are satisfied, then we can say that f of z is analytic. Okay, so this is the concept here. Understood? So next we'll see the concept of conjugate harmonic functions. Conjugate harmonic functions. Okay, so if f of z is given for you, that is u of x comma y plus I into v of x comma y. Okay, so if f of z is analytic function given for you, and you are given with u, and you are asked to find its conjugate harmonic function. Conjugate harmonic function, that means you have to find v. If you are given with v and asked to find conjugate harmonic function, then you have to find u, that is u comma v are conjugate harmonic functions, or conjugate harmonic functions to each other. Okay, they are said to be conjugate harmonic functions to each other. Okay, so first of all they have to satisfy the harmonic function concept, that is uxx plus uyy is equal to 0 and vxx plus vyy is equal to 0. If they are satisfying these conditions, then they are said to be harmonic, and if both are satisfying these conditions, then they are said to be conjugate harmonic functions to each other. Okay, that means in the questions what they will ask you is, they will give you real part of f of z is some function they will give you, and they will ask you to find conjugate harmonic function. Find conjugate harmonic function, they will ask you. That means they are giving you u and they are asking to find v. So once you have u and you are going to find v, then you can find f of z also. So sometimes they will give you to find f of z also. They will give you to find f of z also. So how can you write f of z? F of z is equal to u plus iv. So you are given with u, and now you are going to find v using the concept which I am going to tell you now. So once you find v and you have u already given, then you can write f of z, which is the combination of u and v. Okay, so these are the models possible to ask using conjugate harmonic function concept. Okay, try to understand the concept clearly. Right, so if you are given with u, suppose you are given with v of x comma y is given for you, and you want to find its corresponding conjugate harmonic function. Conjugate harmonic function, that is you have to find u of x comma y. Then what is the procedure is, you are going to find u, so you have to write u is equal to ux dx plus uy dy. This is the first step you have to write, ux dx plus uy dy. So you can't find ux and uy because you are given with only v of x comma y, and u of x comma y you have to find. It is not given, so this is not possible directly. So we are going to make use of Cauchy-Riemann equations. Cauchy-Riemann equations. From Cauchy-Riemann equations, what is ux? Ux is equal to vy and vx is equal to minus uy, and vx is equal to minus uy. So substituting that, what you will get, ui is equal to, in the place of ux you can write vy, so this is vy dx. In the place of uy you can write minus vx dy. Okay, so this is what you have to find this is du. Okay, so this is du, sorry, not u, I have written wrongly, sorry. So this is du. So how can you find u? U is equal to, when you have of this form from differential equation concept, it is integral vy dx, treating y as constant, plus terms independent of x in minus vx dy plus k. Okay, so this is all the function u is. So u is equal to integral of vy dx. So du send this side, so it will be integral. So integral of vy dx, treating y as constant. This is important. All the terms, all the y terms, you have to treat them as constants. And here you have to take the terms which are independent of x. Okay, independent of x means the term which is not containing x. You have to take only those terms in vx. Already vx is obtained for you. So in vx, the terms which are independent of x only you have to include in this second integral. And when you are doing the first integral, you have to treat the y, the y as constant. Okay, so variable y is taken as constant because the integration is with respect to x. Treat y as constant. Okay, this is the formula which you have to remember. Okay, so just remember the formula here, and in the next video I'll clearly solve some of the questions so that you can get a clear concept of how to solve these conjugate harmonic functions. Okay, similarly for polar form also, if you are given with v of r comma theta and asked you to find the conjugate harmonic function, find conjugate harmonic function, so what you have to find is u of r comma theta. U of r comma theta. So you have to find u. So du is equal to ur dr plus u theta d theta. But you are given with v and you are not given with u, so you can find ur and u theta directly. So we'll use of Cauchy-Riemann equations. So what are Cauchy-Riemann equations? Ur is equal to 1 by r v theta. Similarly, vr is equal to minus 1 by r u theta. So in the place of ur, we can write 1 by r v theta dr, and in the place of u theta we can write r vr. So u theta, so send this r vr this side and r this side, and also negative sign. So it will be u theta is equal to minus r vr. So u theta is equal to minus r vr. So in the place of u theta I am substituting with minus r vr d theta. So therefore u is equal to integral of 1 by r v theta dr. So since the integration is with respect to r, treat theta as constant. Theta as constant plus terms independent of r in minus r vr. Terms independent of r in minus r vr d theta plus k. Okay, so this is the formula which is used to find the value, find the function u. Okay, so if you are given with v of r comma theta, you have to find u of r comma theta. So once v of r comma theta and u of r comma theta is obtained, you can find v of f of z, which is given by u of r comma theta plus I into v of r comma theta. Sometimes in board exams they will ask you this. Okay, so once you are given with u of r comma theta and you are going to find u of r comma theta, just substitute those values here, you will get the function f of z. Okay, similarly the concept of orthogonal trajectory. Orthogonal trajectory is also same as this conjugate harmonic function only. Okay, so if you are given with some function, okay, so if you are given with some function and asked you some function like x square y minus yx square is given for you and asked to find its corresponding orthogonal trajectory. So what you have to do is treat this as u and find v, and find v by using this conjugate harmonic function concept. So that will be the orthogonal trajectory. That means u of x comma y and v of x comma y are orthogonal to each other. Orthogonal family of curves. Orthogonal family of curves. Okay, this is not a new concept. If they ask you orthogonal trajectory, treat that as u or v and find its corresponding conjugate harmonic function only. Okay.